Hello everyone, in this video I explain increasing and decreasing function by using the differentiation. Let us start. This is a curve y equals f of x. This is x-axis. This is the top and this is the bottom. At the top and at the bottom, the gradient of the curve equals 0 because the tangent is parallel to x-axis. So at this point, the gradient of the tangent is 0. So at this point, dy by dx equals 0. dy by dx equals 0. So this point, let this point denoted by x1 and this point denoted by x2. So that 2 points are called the stationary points. Stationary points. Now, the gradient here to the left of this point, so the gradient of the curve makes acute angle, it means the gradient is positive. So to the left of this point, dy by dx is positive. So the gradient, the sign of dy by dx is positive. So dy by dx it will be positive. So we say it is increasing. So the function increasing when x less than 1. We do this arrow, it means that the function is increasing. So it is increasing function here. Why it is increasing? Because the gradient of the curve is positive, makes acute angle. Now, after x1, if we draw the gradient of the tangent, or if we draw the tangent, so the tangent in this part of the curve is negative. So dy by dx is negative. Why? Because it makes obtuse angle with the positive direction of x-axis. So between x1 and x2, the gradient is negative. So it is decreasing. So in this part or in this region, the function is decreasing. After this point, the tangent is positive, makes acute angle. So dy by dx is positive. So after x2, dy by dx is positive. So we say the function is increasing. So f of x is increasing function. So to check the increasing, the decreasing, and the stationary, we use the sign of the function dy by dx, the sign of derivative function, the sign of f of dash x. So to check the increasing and decreasing, we use the sign of the derivative function f of dash x or dy by dx. Remember, to get increasing, so in increasing and decreasing, check the sign of f of dash x. Check the sign of f of dash x. Let us we see example 1. It is in page 95. For what range of values of x is the function y equals x cubed minus 3x squared minus 9x plus 4 decreasing, increasing, or stationary? To start the solution here, we find dy by dx. So this is the first step. So the first step, we find dy by dx. 3x squared minus 2 times 3, 6x minus 9. The second step, equate it by 0. So the second step, dy by dx equals 0. So 3x squared minus 6x minus 9 equals 0. We solve this equation by using mod 5.3 in the calculator. The solution of this equation by using the calculator, x equals 3 or x equals -1. The third step of solution, we draw the number line. So this is the number line, it's x-axis. We put the numbers in order, the roots in order. -1 and 3, -1 comes first, so this is -1, and then this is 3. We check the sign of dy by dx. So we check the sign of dy by dx. The sign of this one, dy by dx. How to check this sign? First, we have a point between -1 and 3. The best point between -1 and 3 is 0. So we check 0 there. Replace x by 0. When you replace x by 0, so 0, 0 minus 9, it becomes negative. So dy by dx in this part is negative. So the function is decreasing. So the function is decreasing. So in this function, in this part, decreasing function. Now we choose a point before -1. Before -1, we can check -2. Replace x by -2. Because this is a quadratic function, it will be positive, negative, positive, or negative, positive, negative. Because we are sure at the middle, in between negative, so we will get positive. When you replace x by -2 in this function, you will get positive value of dy by dx. So it is increasing. In this interval, increasing. Also this one, we can choose point more than 3, for example 4. When you replace x by 4, dy by x, it becomes positive. So it is increasing in this interval. So it is increasing. Now we can solve this part of the question when, okay, for which values of x is the function decreasing. So we say decreasing, it is in between. So we say for x greater than -1 and less than 3, f of x decreasing is decreasing. And when x is less than -1 or not and, so for x less than -1 or, take care, don't say and, or x greater than 3, f of x is increasing. Stationary at x equal -1 or x equals 3. So for x equals -1 or x equals 3, the function f of x is stationary. Let us go to the examination exercise and we select questions. This question 16, page 127, this question from examination exercise. Determine the range of values of x for which the function is increasing if y dash. In this exercise, we don't have f of x. So we have direct the differentiation. So what we do, we check the sign of f of dash or we check the sign of y dash. Y dash or f of dash, it is the same. Now we check the sign. To check the sign, the first step, we find the root. Equate y dash by 0. So the solution of this question starts with that. Put y dash equals 0. So when you put y dash equals 0, x squared plus 6x plus 5 equals 0. We use the calculator to solve this one, mod 5, 3. So the solution of this equation by using the calculator is x equals -1 or x equals -5. That are the roots of y dash. The next step, what we do, we draw the number line. So this is the number line. We put the roots in order, -1 and -5. -5 is less than -1. So -5 comes first, and then -1. Now what we do, we check the sign of f of dash, or we check the sign of y dash. Now, at -5 and -1, y dash is 0, stationary point. So already here it is 0, 0. Now we check, we choose the values here. So -5 and -1, we choose, for example, less than negative 5, we can replace x by negative 6 in y dash. We check the sign of y dash. So y dash when x equals negative 6. Replace x by negative 6. So it's a negative 6 squared plus 6 multiplied negative 6 plus 5. 5, it means positive. So in this interval, the function is y dash is positive. So we say it is increasing. So in this interval, it is increasing. So it is increasing. Now we check value between, because he said when it is increasing. So we check a value between negative 5 and negative 1. For example, we can choose negative 2. So we check the sign of y dash. So y dash when x equals negative 2. Replace x by negative 2 in y dash. So negative 2 squared plus 6 multiplied negative 2 plus 5. Is negative 3. So it is negative. It means it is decreasing. Of course, in this part it will be increasing because it is the second order or quadratic equation. But we can check, for example, you can check by 0. So when you replace x by 0, it will be positive. Y dash, it will be positive. So it is increasing. Now, he said values of x. The function is increasing. The function is increasing when what? When x less than negative 5, when x less than negative 5, take care. Or, don't say and is wrong. When x less than negative 5 or x greater than negative 1. So this is the solution. Let us we see this question 21, page 128. If the function f of x 1/3 x cubed plus ax squared plus x is an increasing function for all real values of x. So it is always positive, not be negative, not be 0. For all values of x, find the range of possible values of a. Now, let us revise some important thing. For the function y equals x squared, for the function f of x equals ax squared plus bx plus c. This is a quadratic function. When we draw this quadratic function, we have this form. So this is x-axis. If a is positive, so the curve is open upwards. So the curve may be like this, or like this, or like this. If the coefficient of x squared is positive, so the curve is open upwards. When the curve intersects x-axis at 2 points, it depends on the discriminant, delta, which is b squared minus 4ac. In the first case, if delta is positive, so in this case, b squared minus 4ac is greater than 0. Okay? In this one root, when delta equals 0. So when b squared minus 4ac equals 0. In the third part, when delta is negative. So in this part, when b squared minus 4ac negative. Again, we have 3 cases of the curve of quadratic function. The quadratic function intersects x-axis at 2 points. We have 2 different free roots. If b squared minus 4ac is positive, intersected the curve at 1 point, so we have 2 equal roots. If b squared minus 4ac equals 0, does not intersect the x-axis, so we don't have real roots. When b squared minus 4ac is negative. In that one, the function is always positive because it's up to x-axis. So it's always positive. So when we say the function is always positive, we must have 2 conditions. The first condition, a is positive, the coefficient of x squared is positive, and b squared minus 4ac is negative. The discriminant is negative. B squared minus 4ac is negative. Now we go back to our question. The solution here, the first step we find f of dash, because we check the sign of f of dash. So f of dash x, the differentiation. 3 comes down, 3 times third, it's 1, x squared, plus 2 comes down, remember a is constant. So 2 times a, it's 2ax, plus differentiation of x is 1. He said it's always possible. Look, please here, the coefficient of x squared is 1. So this is the first condition, a is positive. And now the second one, because he said it is increasing for all values, so the condition is that b squared minus 4ac is negative. This is the condition. But what is a, b, and c in this equation? A equals 1, b equals 2a, and c equals 1. Now we solve this inequality. So, how to solve this inequality? b equals 2a, so it's 2a squared minus 4ac, 4 bracket, the value of a is 1. The value of c also is 1. The condition, the second condition is that the discriminant is negative. So this one is less than 0. Now we solve this inequality. Minus 4 less than 0. Now we need to solve this inequality. How to solve this inequality? We say let 4a squared minus 4 equals 0. So 4a squared equals 4. A squared equals 1 when divided by 4. From this a equals positive or negative square root of 1. So it means positive or negative 1. Now we draw the number line. 1 and negative 1, that are the roots. So negative 1 comes first and then positive 1. And now we check the sign of this one. 4a squared minus 4. We check the sign of this when it's negative. Now it's better to choose a value between negative 1 and 1. We can choose 0. So when you replace a by 0, it will be negative 4. So it will be negative in this one. So 4a squared, the other one it becomes positive when you choose less than negative one is positive, and also in this part it will be positive. So the b squared minus 4ac, it will be negative in this part. So the possible value, so the possible values of a is that range a included between negative 1 and positive 1. Because when a included between negative 1 and positive 1, b squared minus 4ac, it will be negative. So this function is always positive. It means when we draw it, it will be up to x-axis. So this is the function in this case. So it will be up to x-axis. So the function is positive when 4a squared minus 4 negative. It means a included between negative 1 and 1. I hope you understand this question. Thank you.